Hello, we are Microgrid Cost Reduction Team 1, and we will be discussing the process behind our cost reduction framework within microgrid systems. Our sponsor, Alternative Energy Development Group, tasked us with generating cost reduction strategies that can be implemented into the main framework of a microgrid. In order to successfully execute our framework, it will need to lower transmission costs, utilize current technology, be feasible to implement, have the ability to be standardized, and offer savings to consumer and producer.
So we began our project by researching 6 possible cost-saving strategies. From there, we researched more to come to a conclusion on the 3 with the most potential. For each of the 3, we began producing simulations and equations to determine how much the cost could be saved in the design of the microgrid. One design element used was DC distribution lines. In typical grids, long-distance transmission lines are needed. However, due to the smaller size of microgrids, those are not necessary to use, and incorporating DC lines allows us to reduce the amount of times the current must be converted between AC and DC, which helps eliminate sources of loss, as well as requiring fewer components in the system design.
The energy management system integrates solar, natural gas, load shedding, and battery storage through computer programming. Demand is met economically by optimizing the output of the given resources. The savings are calculated based on the difference between the EMS algorithm's instantaneous operation and manual operation.
Cost-effective energy exchange strategies needed to operate ESDs more efficiently. Energy storage devices require that there be minimum energy in the ESDs to avoid the ESDs being completely depleted to avoid blackouts. Controlled charging and discharging algorithms for the dispatchable energy of the device based on hourly electricity prices is developed.
Following were the results for cost reduction framework. The DC wire distribution is 3 to 4% more efficient as compared to the AC system. The new system requires few components and lasts longer due to less internal heat generation.
The EMS algorithm saved just over 20% of energy output by the microgrid. This translates to savings of 4.83 megawatt hours per day for every megawatt of installed capacity. This 20% energy savings value is not applicable to all microgrids. However, the simulation as a whole is proof that an EMS provides substantial economic benefit to a microgrid.
The energy storage device calculated to utilize the mathematical model to determine the minimum energy level and discharge rate of ESDs for evaluating energy exchange cost. Using our developed MATLAB algorithm, within 6 hours of power interruptions and hourly electricity prices from 2017, the financial benefit was calculated to be $1,128.89 per year.
Overall, our cost reduction framework proved to be effective, and we fulfilled our goal in satisfying the needs of the consumer and the requirements of the project.